Okay, for our third reaction, this is again an alkene addition reaction, right? So we're going to start with an alkene, and now we're going to add HX plus hydrogen peroxide. So we're going to add HCl or HBr plus H2O2, all right? And it turns out that the addition of H2O2 changes the mechanism completely, right? So if we just had HBr, we just saw that reaction, and that follows a mechanism that goes through a carbocation. But when we add H2O2, this is now going to go through a radical or a one electron mechanism, okay? So there is no carbocation, everything's different in the mechanism. And right now, we're not ready to talk about radical mechanisms. We're really going to discuss this later on in the semester. So in fact, we're not actually going to cover the mechanism for this. So I will not ask you the mechanism, and you don't need to know it. So what we really need to know, though, is what are we doing? What are we adding? So again, we're going to, as an alkene addition reaction, we're going to break the pi bond, not the sigma, break the pi bond. Again, we're going to be adding the H and the X. But what's important here is this little addition of H2O2 means we're now going to add the bromine to the anti-Markarnikov position. We're going to do the opposite of Markarnikov's rule, right? Remember, Markarnikov's rule says add the hydrogen to the side where there's more hydrogens. Now we're going to add the hydrogen to the side where there's less hydrogens, all right? So you don't need to know the mechanism, but we need to know this reaction, right? It doesn't mean that this reaction is any less important, right? So if we look at our alkene here, here's the two sp2 carbons. The carbon on the left is attached to two carbons. The carbon on the right is attached to a hydrogen and one carbon. So this carbon on the left, that's sort of our Markarnikov position, right? So normally we would add our X to that position. But because this contains H2O2, we're not going to follow that. We're going to do the opposite of it. So we're in fact going to add our H, right? We're going to be adding our H to the left side in this case, and then adding the bromine to the right side, all right? And this is the product that we get, all right? So we can simply draw the product out like this. That is the final product that we get. So let's look at another example here. I'll take a ring. Okay, so we're going to treat this with HX. Here we'll do HCl, and we're adding H2O2. Okay, so here are the two sp2 carbons, right? In this case, the carbon on the top, right, has a hydrogen. It's less substituted. So because we're going to be following sort of the anti-Markarnikov model, that means what we're going to be doing is we're going to be adding our chlorine to the sp2 carbon on the top. So that would be our final product in this case, all right? So in this reaction, we're doing the opposite of Markarnikov's rule, right? That's why here our little cheat sheet here says that this is anti-Markarnikov addition, all right? And what you notice is you don't have to worry about any stereochemistry here, right? These are solid lines, which means you get a mixture of enantiomers and diastereomers. So here we just draw straight lines, no dashes or wedges. We don't have to worry about any regiochemistry.